Hi, in this video we are going to be looking at special properties of logarithms. The first special property reads logarithm base b of 1 equals 0. So we have a couple of options. We can either memorize that or we can try to generally build it up. For me, I try to memorize only what I really have to. I try to understand as much as I can. So let's just say that we didn't have the answer and the problem is just simplify that expression. So we are asked to simplify logarithm base b of 1. So if I just remember that the punchline that the logarithm is just an exponent, what the question now boils down to is, let's go ahead and take that base. So we have base raised to some power will give us the argument of 1. So I'm like, okay, b to what power simplifies to 1? So in this case, we have to remember stuff from the past. We have to recall the zero exponent rule, okay? The zero exponent rule states that for any non-zero number, when we raise it to the 0 power, that would always evaluate or simplify to 1, positive 1. So I'm thinking, okay, b to what power equals 1? I'm like, okay, yeah, b to the 0 power equals 1. So in this case, the answer is just 0, like the property told us. Special property number 2 reads logarithm base b of b equals 1, and then same speech, we can try to memorize it or we can generally try to build it up. Let's go in the second direction. So we're going to look at the base of the logarithm, which in this case is b. And then I'm going to start off with the base, and then just remember what a logarithm is. A logarithm is just an exponent, so I'm thinking b to what power is going to give us the argument of b. So I'm thinking, okay, b to what power equals b? I'm like, oh yeah, b to the first power equals b. So in this case, the logarithm base b of b simplifies to 1. Third special property reads logarithm base b of b to the k equals k, and then same speech, we can just memorize it or try to build it up. Let's go ahead and build it up. So we're going to start off with the base of the logarithm, which in this case is b, and I have to remind myself what a logarithm is. A logarithm is just an exponent, so I'm thinking b to what power is going to give us the argument b to the k. Okay, so I'm thinking, okay, b to what power equals b to the k, and I'm like, oh yeah, b to the kth power equals b to the k. So the mystery is k. So I'm going to show you something that maybe your instructor won't like, but it's okay. We do what we got to go do. We do what we have to do. So we have logarithm base b of b to the k. I pretty much told you how we can go about it, but I'm going to show you my secret weapon. So we have to remember that the exponential function and the logarithmic function are inverse functions. So let's go ahead and look at the base of the argument, which is b, and let's go ahead and look at the base of the logarithm, which is b, and let's go ahead and look at the base of the argument, and it's also b. Since the bases are the same, they pretty much undo each other, and that will leave us with the exponent of k. Okay, so I don't really care how you get your answer. No one's gonna know. Okay, so let's go ahead and do a couple of fun problems. I guess I know how to count 5 of them. Let's start from the beginning. So problem A, we have logarithm base 12 raised to the 12th power. So we can do this in 2 ways. Let's just go ahead and do it how we did it initially. So we're first going to start off by looking at the base. So I'm thinking base to what power is going to give us the argument of 12. So I'm like, okay, 12 to what power equals 12? And I'm like, oh yeah, 12 to the first power equals 12. So the answer is just 1. Problem 2, we have logarithm base 3 of 1. For me, it's really hard to answer mentally, so I'm going to try to build it out. So we start off with the base. The base is 3, so I'm thinking 3 to what power is going to give us the argument of 1. Then I have to remember, oh yeah, 3 to the 0 power will give us 1, so the answer is just 0. Problem number 3, we have logarithm base 4 or 4 to the 7th power. So the question is, what does that evaluate to? So if we look at our third special property, of logarithms, we have that the base of the logarithm is 4, the base of the argument is 4. Since the bases are the same, they undo each other, and that will leave us with 7. Okay, or we can do it how we did problems A and B. Alright, problem D. So almost grand finale. So problem D, give me a sec, gives a logarithm base 4 of 64. So then I guess I'm gonna try to do it by inspection. Okay, so I'm thinking, okay, base to what power gives us 64? I'm like, okay, 4 to what power is 64? 4 to the first, 4 to the second. I think it's 4 to the third. Yeah, because 4 to the third power is 64. Okay, so in this case, logarithm base 4 64 gives us 3. You can always use your calculator if you wanted to check it. For the grand finale, whew, about time. Hi, I had a little technical difficulty, but the good thing is that I have a band-aid. So let's go ahead, wrap this up with our final problem. So problem E for the grand finale, we have logarithm base 2 of the square root of 8. Now, it would be really nice if I could generally evaluate this mentally. Like problem D, we have 4 to what power equals 64, and we're like, oh yeah, 4 to the third power is 64. But for problem E, that's a little bit more difficult for me. I'm like, 2 to what power is equal to square root of 8? I have no idea. I don't know about you. So let me go ahead, start a thinking error. So we have the base is 2. So 2 to what power is equal to square root of 8? I have already confessed to you that I don't know what the answer is, so I'm just going to try to write this in exponential form. So pretty much write it without the radical. So a little quick review, how to go from radical notation to rational exponents, or put it in exponential form. So if we have the nth root of b to the m, to write it without the radical or exponential form, we are going to keep the base and write the exponent as a fraction. So to do that, we're going to take the current exponent and divide it by the index. So square root of 8, to write it in exponential form or without the radical, we're going to take the radicand. I think I may have said that incorrectly, sorry. And then we're gonna raise it to some power. So what is that power? So it's gonna be current exponent divided by the index. So the current exponent is 1 and the index is 2. So we have the square root of 8 is just code for 8 raised to the 1/2 power. So again, question is 2 to what power equals 8 to the 1/2? I have no idea. But I know that you know that 8 is the same as 2 to the third power. So let's just go ahead, write so, and see where that takes us. Then we're going to go ahead simplify this by using the power rule. So gentle reminder, so the power rule for exponent says this: if we have a factor and we raise it to some power, we're going to keep the base and multiply the exponent. So our power is 1/2, so let's apply the power rule. We're going to keep the base and multiply the exponents. Last time I checked, product of 3 and 1/2 is 3/2. My band-aid is moving. And that will give us 2 raised to the 3/2. So let's go ahead and bring down the rest of our problem. So again, the question is logarithm base 2 of square root of 8, sorry about that, equals what? So 2 to what power equals 2 to the 3/2 power? I'm like, okay, 2 to what power equals 2 to the 3/2 power? I'm like, oh yeah, 2 to the 3/2 is going to equal 3/2. So the moral of this story is that the logarithm base 2 of the square root of 8 simplifies to 3/2. Oh, you just got a glimpse of my blooper reel. Okay, thanks guys.